Cool. Like, this talk is about the Polkadot roadmap to Gem. And yeah, who is more or less clear about the Polkadot roadmap and what Gem is? OK, not too many people, so that's great. And who has IT background? OK, so I want to make sure here about some terminology. And Polkadot, as we know it today, is a computer. Essentially, we can think about Polkadot and the validators. Polkadot validators are grouped into different cores. And these cores have 5 validators each. And they are the resource of computation of Polkadot. So this is kind of like a CPU kind of thing. When I talk about cores, are not real cores in computing, but are these validator groups that they actually rotate between cores, and they perform this computation. And yeah, when I also talk about L1, it's not L1 cache or this kind of things. It's just layer 1 and normal like blockchains, like the typical blockchain that we know today, like Solana or Bitcoin or Ethereum. Right, let's start. Checkpoints of this talk are the Beefy protocol, which ensures trustless communication with other like protocols that are different from Polkadot. Then asynchronous backing, agile core time, elastic scaling, the minimal relay chain, and then Gem. Probably some of these concepts were already mentioned during the Decoded in other talks. I will briefly dive in each one of those. Again, what is Polkadot is a multi-core CPU. We have currently 50 cores. And you can imagine within each core, there are different validators that they put their machines for the protocol in order to perform computation. And what Polkadot does, essentially, it's a roll-up chain where we have different roll-ups, different like layer 1s, different blockchains. They connect to these cores. And what Polkadot does, replace everything, make sure that everything checks and provides security, putting everything in a shared state in the Polkadot relay chain. So everything is packed in this coherent state that is like Polkadot. Polkadot provides security to these chains using these cores. Yeah, we have, as I said, 50 rollups, of which 3 are called system chains. These are native system chains, like system processes in computing. We have similar things for Polkadot with system chains that are bridge hub, collectives, and asset hub. Collectives, we already have the Polkadot fellowship and the ambassador program that are on-chain within the collective system parachain. And within the bridge hub, now we also have Snowbridge, which is this Polkadot Ethereum bridge that was recently launched. What Polkadot does, essentially, is you can see at the bottom of this scheme, we have all the cores, which is basically the hardware, is the computer. And then on top of this, we have the kernel, so how these resources are managed, input and output. So Polkadot essentially is managing all these things right now. The parachains, protocol, DOT, the staking, the governance, everything is still within this fat kernel. And then on top of this, we have actually the user land, where we have all the parachains. And user, I mean, can be normal user, but also developers that they're developing parachains. So this is kind of the current situation. Briefly, I want to talk about Beefy. Beefy is this protocol that sits on top of Grandpa. I don't know if you are familiar with how Polkadot works, but it's split in between 2 kind of systems. We have the Babe, which is the block production algorithm. And then we have Grandpa, that is the finality. And on top of Grandpa, now we have Beefy. And this is a very efficient system that enables trustless communication. Essentially, it is very easy now to verify the state of Polkadot without tracking forks. So with Beefy, it's very enable very fast state verification. And this is very important for trustless bridges, permissionless trustless bridges like Snowbridge, like Hyperbridge that will be launched very soon. And yeah, the idea here is just we want to 60% actually of all the hacks happen on bridges, centralized bridges. And we want to avoid this. And the idea is to have a bridge that is fully trustless, where if something goes wrong, is the fault of the validator in one or the other chain that wasn't able to provide, like, or like was the verification or was malicious. So you want to slash the validators. You don't want to slash the relayers. And you can also recover the funds because everything can be proved on chain. So this is kind of next level of trustless bridging, away like from Polkadot to other ecosystems like Ethereum. We will have other bridges to, I don't know, like other ecosystem like Solana and so on. Hyperbridge, it's again another type of bridge. Snowbridge is one type of bridge that we already have. Soon we will have also Hyperbridge that will bridge to many different other ecosystems, not only Ethereum. It will be trustless and is ZK based, which means that it's very fast from the prover side. And we have kind of 5-7 minutes transfers. It's multi-chain. Again, like you can see here, Arbitrum, Optimism, and other chain will be bridged to Polkadot. And essentially, Hyperbridge will be a co-processor, will be acting as a parachain, and will be able to bridge all these different chains, you know, to each other. And the fact that Polkadot is providing security and is also providing a shared state, this will be possible to verify the state of multiple chains very easily because of how Polkadot works. This is like something that is enabled only because of Polkadot technology and MiFi. Asynchronous backing, which is already real on Polkadot, is able to speed up to 10 times more the block production for parachains. And essentially, parachain will be able to have way faster data throughput. And Polkadot will be able to keep it secure without like compromising the security overall that we have now. So it's a protocol level efficiency kind of improvement in the ecosystem. NOMT was mentioned a little bit. I think this was added again. Like I did like I edited the slides, but I think was not reflected here. But anyway, NOMT is another way to boost additionally the throughput of Polkadot and also other protocols. It's near optimal Merkle trees. It's a little bit complicated, but here essentially what it means is that it will provide 10 more faster reading from a blockchain. Because currently the bottleneck of blockchains is that these cores do a little bit of computation, then they need to read and write to the SSD of the machines, and this is the bottleneck that we currently have. So the collators, the validator need to read the state, do a little bit of computation and write. So you can do as much as you want, but there is this bottleneck of reading and writing to this SSD. And NOMT provides a possibility to speed up even this stage with a 10x faster improvement in block building for L1s, for parachains, and up to 50% reduction in POVs, proof of validity, is what actually layer ones are sending to Polkadot for being secured. So it will be a way more efficient system of, again, improving data throughput. With the CPU analogy, I don't know, here I like to make a visual comparison with computers. If you have the task manager in Windows, you also have like a way of visualizing the load on the CPUs. And the current system for Polkadot is the current that you have different cores, as I described. And then one application is running on one core, and another application is running on another core. And this is fixed. It cannot be changed. It's a very static system. And here there is an example of an application running on core 1, and then a system application like Asset Hub running on core 2. A new thing that, that is coming is Agile core time. Agile core time will allow not anymore to have this fixed partition. So we will not have anymore one parachain, one core, but it will be able to use a core and split it between different chains. For example, I am a chain. I want to use core 1. So I buy time on this core. And then at a certain point, I realize I don't need it anymore. I split it, and I sell it to another chain. And that chain can connect directly to core 1. So you can see, like on the left, the splitting system is a core that is running for one process, and then stop that process, is running another process. Or you can have this interlacing system where it's more like you go on this core, I go on this core, you go, I go, and then it's like this, like interlacing in this way. So it's a more agile system that provides lower barriers of entry to Polkadot. So you know that Polkadot has auctions. There will be no auction anymore. You buy core time, you buy with DOT, DOT gets burnt, the DOT revenue gets burnt, and you get access for a limited amount of time to this resource of computation that are Polkadot cores. Elastic scaling is another way of parallelizing kind of the processes across multiple cores. It's not one or the other anymore, it's one and the other. So you can see like core 1 has one process that is fully using that core, and then the same process can use an additional core. So you have a two-core kind of parallelization, and at the same time, maybe core 2 can interlace with another process. So you can see here how we are moving more towards today's computation, today's computers. So what Polkadot is trying to achieve is to use this resource of computation as agile as possible, like traditional computers today, they do like this. So up until here, asynchronous backing, agile core time, and elastic scaling is what the community decided is Polkadot 2.0. It will be delivered this year. And essentially, what Polkadot is right now, we have this in-core, on-chain dualism that I didn't really talk about up until now. But essentially, you have these validators doing something on these cores, but then also pushing stuff on the chain. And this is something new that no other system do. It's called execution sharding, where you are basically splitting the work, the computation work, across a subset of validators, instead of making the validators do everything and repeating themselves all the time. That is not a very scalable system. So we are scaling computation by taking a subset of machines in these cores. And then what happens is that with a data availability system, all the machines can still verify everything later on if there is a dispute or something like that. And yeah, this is made secure by the Polkadot parachain protocol that is called ELSE. It has been released, a paper, very early on this month. If you want to read it, it's very interesting. So there is some cryptoeconomic security behind this. So it's a very secure system, but still highly scalable. So Polkadot is a very performant machine because of this in-core on-chain dualism and this data availability. That, by the way, it's not programmable. Developers on the parachain cannot actually use this data availability system. The cons is that Polkadot is a permanently sharded chain. And maybe you were at other Gavin's talk. This is something that has been emphasized. Polkadot is a permanently sharded chain, which means that different layer ones cannot talk to each other. They cannot mix. They cannot be very synchronous. And this has been a big problem compared to other chains like Solana or like Ethereum that are more synchronous, and this allows to have a synchronous application. Everything gets, how to say, like different contracts can cooperate in the same block at the same time. It's much faster. So this is still a problem of Polkadot. And this permanently sharded thing creates an incoherent and asynchronous, highly asynchronous kind of system. So the way chain can communicate is with XCM, and it's an asynchronous kind of way of communication. You cannot even pause and stop processes. And we just have parachains. It's just a roll-up system that is good for parachains, but you cannot really like use this cores, this computation for more things. Another thing that you will see, and it's already ongoing, is the minimal relay, like offloading the relay chain tasks to system parachain. So now what Polkadot is doing is that this kernel is doing a lot of stuff. Now what we want to do is to move everything to system parachain. All the balances, all the identities, the proxies, the governance, the staking will not be on the relay chain anymore. It will be offloaded to system processes. And this will make the relay chain more and more transactionless. There will be less and less user transactions passing through the relay chain, because everything will be handled by the system chains. So this is, well, actually, I just said that this relay chain is transactionless and all functionalities away from the relay chain. And the relay chain actually concentrates resources on what it does best, which is securing these rollups, securing these layer ones. This is what actually it does. So the next step, or what is already ongoing, is to shrink this kernel from having DOT and staking and all this stuff away to system chains, and we will just have the parachains protocol within the kernel. You can see how the resource of computation, which are these cores, they stay constant. Polkadot is not changing. It's not that we are changing everything. The CPU, the computation, the way things are, the networking and all this very low-level stuff will stay more or less the same. So why Gem? Gem essentially is the next upgrade of the kernel. It's shrinking even further. It's taking out the parachains and put them in a higher level. It's a way of making Polkadot more coherent and more synchronous, because cores will be able to be shared at the same time with other processes, so things can mix. If I'm a parachain and you are a parachain, we can schedule our processes within the same core. In that 6-second block time, everything gets executed synchronously. So we can do stuff that is way more interesting, like meta applications, stuff that is already possible, for example, in other systems like Solana, which is it's a highly synchronous system, or Ethereum. It will be possible on Polkadot, but it will not be forced. This is also very interesting. We are not forcing people to be synchronous. There will be incentives to, for chains to put in place so that they can schedule their processes within the same core and execute everything in a synchronous way. Then there's a simpler chain specification and custom programmability for devs. I will not go too much in detail, but essentially you have this refine and accumulate thing that maybe some of you already heard from Gavin talks. By the way, Gavin is talking tonight at Web0 event about the gray paper. I recommend you guys to join. And he will dive, I'm sure, more in depth about this. But essentially, it will be easier for people to interact as a core developer to understand how Polkadot works, but also how for a developer how to programmable steps. You can basically custom programmability for all the steps from the refinement to the accumulate and putting stuff into the Polkadot state. Then generalization of services. There will be the parachains service. As I said, parachains will not be part of the kernel anymore. It will be up into, and everything will be organized into services. So what we know today about parachains will be just one service. And there might be other services. Another possible service is CorePlay, which is enabling contract on-chain directly on Polkadot. And essentially, you will be able to pause and resume processes and contracts on cores. If two processes, they schedule within the same cores, stuff will happen synchronously. If they not, there will be an await function that is waiting and then resuming later on. Then better performance with PVM. Everything will be targeting to PVM, which is a RISC-V kind of based virtual machine. Now Polkadot is working with WASM, so it's targeting WASM. Now the gem will target PVM, but nothing will change from the parachain perspective. It's not that substrate will not be there anymore. It's not that everything will be abandoned. Still, everything will be compatible for parachains. There will be backward compatibility. And data availability will be programmable, so developers will be able to use the data availability layer. And yeah, we will have a different system. We will not have Babe as a block production algorithm. We will have Safro, this new algorithm that will ensure the block producer's anonymity with ZK. So we will use ZK to ensure that there is block producer anonymity. You can see, like on the right, that image is showing like this shared core. This is actually what Gem will enable. System can running on the same core at the same time. You can see here an example of a system chain together with another parachain or rollup. They might talk to each other, and they are scheduling their processes within the same core. And this is happening synchronously. This is something that is not possible right now with the current system of Polkadot. So going back to the scheme about the kernel, the idea of Gem is that shrinking again even more the kernel and having everything else to the layer above. And you have different services. You can see that there is the CorePlay service. You have this core chains or like parachains service. And people will be able to create services in a permissionless way, like very much you create in a permissionless way smart contracts on Ethereum. To sum up, this is kind of a screenshot from my MacBook. You can see how cores are shared, how it's very agile, how you can have like a performance core, efficiency core. Very much Polkadot is targeting kind of this aim. To be able to use this resource of computation is the most agile way as possible, lowering the barriers, adding a layer of generality, allowing to run anything on this course, and making sure that everybody can interact with Polkadot and making sure that there is a lot of innovation that is possible. If you want to learn more about Gem and anything, I recommend you to visit the Polkadot wiki. It's currently maintained by myself and the technical education team at the Web3 Foundation. We try to keep it up to date, and anything from, everything about Polkadot should be in there. And if there is not everything, reach out to me. I'm Filippo Web3 on Twitter. You can reach out and or just comment on my post. I don't know, like whatever. You can stay in contact with me, and I will make sure that we add everything to the wiki. Thank you.